When I first heard about something called the baking tray tube tester, I honestly thought it was a bit of a joke. But it's not. Grant Wills really did design one, and he really did build it into a baking tray. And ever since then, it's developed a bit of a cult following. The crazy part is you can build one for well under $100 if you're careful with your parts. Now, I already own commercial tube testers that cost many times that, so the idea that something this simple could replace them was kind of laughable. Until I actually built one. And the funny thing is, I don't actually reach for those expensive tube testers anymore. Not because this tester does more, but because after simplifying the design and sort of building a workflow around it, I actually get the information that's more useful for my day-to-day work. So I didn't build Grant's design exactly as he drew it. His original project is brilliant, but it's designed to cover loads of different types of valves. I don't really need that because I'm a guitar tech, so I just stripped it back to the valves that I see every day. So I'm able to test the most common preamp and power tubes that guitar and bass amps use. I've got a few meters in there to get some measurements. I've got a gas test button, an automatic short tester, and that's it. It's simple, fast, and it's purpose built. Now, if you're interested in building exactly this version, I've got a schematic on my website. And if you're a Workbench member, it's free for you guys, but please don't think you need my version. Grant's original project is completely free. I've got a link in the description because this wouldn't have all been possible without the work that he put in. So the hardware is actually only half the story. What really changed things for me was the software. So I built this app to work alongside that tester, and it really takes away all of that guesswork. Let me show you how it works. So the link's down in the description. Here's the app here. Now, in the valve type section, we've got a list of all the valves that this thing can test. Let's stick with EL34. The unloaded B+, you don't really have to worry too much about that. And we'll keep it in real world mode. Now, all you're gonna be doing is put that valve in, heat it up, and then I've got some presets here. So my grid bias voltage I set to -14. The plate voltage normally sits at around 215 volts on my tester. You can change that. And then you're gonna put your measured current in the bottom here. So let's just say we measure 30 milliamps. Okay, and it comes up with a status replace soon, and it lets you know your cathode efficiency of 64.3%, and it gives you a little indicator here of the health of that tube. Replace soon is where that one is sitting at the moment. So that is how easy it is. If we change it to a 12AX7, you'll notice now I've got two triodes here. So if this one came in at 1 and this one came in at 0.9. So you can see here that it says it's normal. So it's sitting in that normal range. If we change this to strict, it really changes those parameters, which fails most tubes, to be honest. So it's worth noting that I did train this using loads of JJ's data sheets, and then I calibrated it using my testers that I already have, testing it alongside them for a few months to make sure that this actually works as well as my other testers. And in this current setup with this app, for me, it's working so much better. It's so much easier to see where that valve is actually sitting. And the great thing is there's no guessing, there's no sort of wading through data sheets to see if your valve's okay. You just put in the numbers and you get a result. And if you've built one of these testers before, this is free to use. So there's a link down in the description, check it out. As far as bonus features, I've got a bias calculator on here as well. So if we click here, it's got a bunch of valves here, obviously no preamp ones. And if we click the EL34, if we set the plate voltage to say 390 or something like that, if we're looking at 70% dissipation, which is pretty standard, it tells you the calculated target here. You can put in yours here, just say if you got like 39, it gives you your readout down here. So it's pretty basic and kind of handy little thing to have added on to a tester, but I'd use this tester a lot. I would say I'm using this tester probably every day. So it's something that's really important to my workflow. Right, so let's test something. Let's put in a 12AX7 in here in the preamp spot and then turn it on. Then we're gonna wait for around about a minute for this tube to warm up. Okay, so I've got the app open over on my computer there, and I'm gonna bring up 12AX7. As you can see, there's two readings there for each triode, and then we're gonna bring this down to -2, grid voltage. Flick this on. Gas test it. This should stop. So with the gas test, when you push that in, you're going to notice it goes up a little bit, that plate current, and then it should sort of stabilize. If it keeps going up, you know you've got a gassy tube. So I'm going to say 0.51 on this side, and then this side, we're going to turn this off, our HT voltage off, flick to the other triode, turn it on. We're going to say that's 0.56.
So as you can see, this tube has failed. Now, I already knew this one was going to fail. It's from a batch that I have saved just for these specific tests. You'll see I've got an extra switch here and a couple of test points. This is where I put my multimeter to test the HT voltage. On a 12AX7, it is always hitting around about 250 on the plate, so I don't really have to worry about it. But with power tubes, it can fluctuate a little bit. Let's see how it compares. I've picked a couple of valves that I know pretty well now. I'm going to test them on the orange tester and the Maxi Matcher, and then the baking tray tube tester. First up, we've got this Groove Tube GT6L6. Let's test it. So on my tester, it's showing that this tube is in great condition. Okay, my Maxi Matcher 2. Now, I love this thing. I've had it for quite a few years now, and it's done a lot of work for me. Let's get this tube warmed up. Now, it's a 6L6, so it's got a little panel here giving you exactly what settings to use. So we're going to, once it's warmed up, we click it into 400 volts, minus 48. It's warmed up. I'm going to push that plate voltage to 400 volts. And it's giving me a 16.6. Right, so this tester is showing it's at the lower end of the scale. Now, that's still a good tube, but I have found with 6L6s, especially on this tester, it does always show them at the lower end of the range, even if they're brand new. And on my baking tray tube tester, it's showing it as excellent. So I always found that really interesting. Okay, so let's try that EL84. Okay, we're going to let this one warm up. I'm going to go to my app, change it to an EL84. So it's really easy to get into a flow when you're doing a whole bunch of tubes at the same time. Now you always keep an eye on your lamp while it's warming up. Now as you can see, this lamp is glowing just slightly, which says to me there is a short in here. If I raise this bias voltage, you'll get closer to 0. See how it's already conducting pretty hard. I'm going to say that's a shorted tube. So I'm not even going to apply my HT voltage. I'm going to say that tube is bad off the bat. It's going to be 325 minus 14. That's another really close to cutoff bias voltage there, minus 14 volts. So I've always had kind of inconsistent results with these, but this should show a short. My one showed a short, so this should also show a short here. That's what I'm hoping. Let's add that plate voltage. Now that's showing a high reading, which is climbing by the looks. See, that's completely unstable. So there's definitely something up with that tube. At the moment, it hasn't detected overcurrent, but it's going to in a minute. Okay, so you can see there clearly it is going out of control. It was going completely out of control there. So that is definitely a bad tube. Right, so lastly, we've got a 12AX7. Wow, this one's pretty bad. 0.09. 0.05. Gas it. That is a heavy fail. I mean, it's barely working. Let's check the 12AX7 in the orange tester. Now, these are only really a good or bad tester, but I've found they are extremely, extremely forgiving with tubes. And I mean, this tube is like completely dead, so it should come up as failed. So as you can see here, it's come up as worn. Now, that is an incredibly hammered preamp tube. There's no way I'd want to put that inside anyone's amp. It should have really failed this test, but this has such a forgiving range. And I know on my app, I've got real world and strict, where real world is a bit more forgiving. And in the real world, this tube should be failed. Now, some people will notice that the baking tray tube tester doesn't measure transconductance, and that's true. Transconductance is a useful measurement, especially when you're doing laboratory testing or matching valves for specialized hi-fi equipment. But for guitar amplifiers, I actually haven't found it something I need, and the reason is transconductance naturally changes alongside valve current anyway. So when you're matching power valves by the actual idle current at the correct operating conditions, you're already accounting for the thing that matters most in a guitar amplifier. And because guitar amps are designed to be pushed, overdriven, and often operated into overdrive, tiny differences in exact transconductance numbers don't translate into meaningful differences in how the amp performs and sounds. So for the work I do, checking customers' valves, finding and replacing weak or bad tubes, and matching guitar power valves, idle current has given me all the information I need. So that's why transconductance isn't super useful in a workshop like this. Now, what surprised me wasn't just the results, but it was the consistency. Some valves would just move around in those commercial testers, pass in one run and then look weak in the next, where the baking tray tube tester just keeps repeating the same measurements. And because I'm working with the actual operating conditions instead of an arbitrary score or a range, I can immediately see where the valve sits compared to its data sheet. And for workshop repairs, that is incredibly useful.
So this started out as one of those projects that was simply too interesting not to build, and I expected it to be a fun and easy project, but I didn't expect it to replace my testers that I've been using for literally years. The tester is easy to use and that workflow is very simple, and the app removes all the guesswork, and together they become one of the handiest tools I've got in my workshop. So if you'd like to build one, check out Grant's original project, and if you'd like to see exactly what I changed, the simplified schematic is available on my website. Now, either way, I hope this inspires a few more people to give the oven tray tube tester a go. Thanks so much for watching, guys, and catch you in the next video.